What lies at the center of a black hole? That is a question that many physicists have struggled with ever since Einstein's theory of general relativity. Are black holes just the relentless maw of death we think them to be, or could they be hiding a secret to this very universe? Let's rewind the clock for a second. Before humans existed, before the Earth formed, before the Sun ignited, before galaxies arose, and before light could even shine, there was the Big Bang. This happened 13.8 billion years ago. But what happened before the Big Bang? Many physicists say there is no point in contemplating that. They insist time began ticking at the instant of the Big Bang, and pondering anything earlier isn't in the realm of science. We'll never understand what pre-Big Bang reality was like, what it was formed of, or why it exploded to create our universe. Such notions are beyond human understanding. But a few unconventional scientists disagree. These physicists theorize that a moment before the Big Bang, all the mass and energy of the nascent universe was compacted into an incredibly dense yet finite speck. Let's call this speck the seed of a new universe. This seed is thought to have been almost unimaginably tiny, possibly trillions of times smaller than any particle humans have ever been able to observe. And yet it's a particle that can spark the production of every other particle, not to mention every galaxy, solar system, planet, and person. If you want to call something the God particle, this seed seems an ideal fit. So how is such a seed created? One idea bandied around for several years, noted by Nikodem Poplavsky of the University of New Haven, is that the seed of our universe was forged in the ultimate kiln, like the most extreme environment in all of nature, a black hole. But before we go further, it is important to understand how the Big Bang happened. The Big Bang theory was born of the observation that other galaxies are moving away from our own at great speed in all directions, as if they had all been propelled by an ancient explosive force. A Belgian priest named Georges Lemaitre first suggested the Big Bang theory in the 1920s, when he theorized that the universe began from a single primordial atom. The idea received major boosts from Edwin Hubble's observations that galaxies are speeding away from us in all directions, as well as from the 1960s discovery of cosmic microwave radiation by Arno Penzias and Robert Wilson. Today, cosmic microwave radiation is interpreted as echoes of the Big Bang. Over the next few decades, further research has continued to help clarify how this violent event unfolded. The theory states that in the first 10 to 43 seconds of its existence, the universe was very compact, less than a million billion billionths the size of an atom. It's thought that at such an incomprehensibly dense, energetic state, the four fundamental forces of gravity, electromagnetism, and strong and weak nuclear forces were forged into a single force. But our current theories haven't yet figured out how a single, unified force would work. To pull this off, we'd need to know how gravity works on the subatomic scale, but we currently don't. It's also thought that the extremely close quarters allowed the universe's very first particles to mix, mingle, and settle into roughly the same temperature. Then, in an unimaginably small fraction of a second, all that matter and energy expanded outward more or less evenly, with tiny variations, providing the fluctuations on the quantum scale. That model of breakneck expansion, called inflation, may explain why the universe has such an even temperature and distribution of matter. After inflation, the universe continued to expand, but at a much slower rate. It's still unclear what exactly powered inflation. As time passed and matter cooled, more diverse kinds of particles began to form, and they eventually condensed into the stars and galaxies of our present universe. There wasn't a single star in the universe until about 180 million years after the Big Bang. It took that long for gravity to gather clouds of hydrogen and forge them into stars. Many physicists think that vast clouds of dark matter are still unknown material that outweighs visible matter by more than 5 to 1, provided a gravitational scaffold for the first galaxies and stars. Once the universe's first stars ignited, the light they unleashed packed enough punch to once again strip electrons from neutral atoms, a key chapter of the universe called reionization. In February 2018, an Australian team announced that they may have detected signs of this cosmic dawn around 400 million years after the Big Bang. The first galaxies were born. In the billions of years since, stars, galaxies, and clusters of galaxies have formed and reformed, eventually yielding our home galaxy, the Milky Way, and our cosmic home, the Solar System. But could the Big Bang have happened multiple times across many different realities? Could there be a replica of the Milky Way, the Solar System, and even Earth in alternate dimensions? Over the last couple of decades, many theoretical physicists have come to believe that our universe is not the only one. Instead, we may be part of the multiverse, an immense array of separate universes, each with its own mysteries that need to be unraveled. How or even if one universe is linked to another is a source of much debate, all of it highly speculative and, as of now, completely unprovable. But one compelling idea is that the seed of a universe is similar to the seed of a plant. It's a chunk of essential material, tightly compressed, hidden inside a protective shell. This precisely describes what is created inside a black hole. Black holes are the corpses of giant stars. When such a star runs out of fuel, its core collapses inward and gravity pulls everything into an increasingly fierce grip. Temperatures reach 100 billion degrees, atoms are smashed to pieces, electrons are shredded to bits, and any remnants of matter are further crumpled for infinity. After this violent collapse, the star turns into a black hole as its gravitational pull is so severe that not even a beam of light can escape. If you use Einstein's theories to determine what occurs at the bottom of a black hole, you'll calculate a spot that is infinitely dense, infinitely small, a hypothetical concept called singularity. But infinities aren't typically found in nature. The disconnect lies with Einstein's theories, which provide wonderful calculations for most of the cosmos, but tend to break down in the face of enormous forces, such as those inside a black hole, or present at the birth of our universe. Physicists like Dr. Pawlowski say that the matter inside a black hole does reach a point where it can be crushed no further. This seed might be incredibly tiny, with the weight of 1 billion suns, but unlike a singularity, it is real. According to Dr. Pawlowski, as a black hole tends to spin extremely rapidly, possibly close to the speed of light, it allows this compacting process to halt and endows the crushed seed with a huge amount of torsion. When these compacting forces are paired with this torsion, it makes the seed not just small and heavy, but also twisted and compressed. At a certain point, these forces become too strong to contain, and the seed expands with a bang. Make that a big bang, or what Dr. Pawlowski prefers to call the big bounce. He states that, in other words, it's possible that a black hole is a conduit, a one-way door between two universes. According to this theory, if you tumble into the black hole at the center of the Milky Way, it's conceivable that you will end up in another universe. Dr. Pawlowski states that this other universe isn't inside ours, but the black hole is merely a link, like a doorway connecting two rooms. Furthermore, this isn't the first time that the idea of black holes being a gateway to another universe has come to light. Over the years, scientists have looked into the possibility that black holes could be wormholes to other galaxies. Some have suggested that they may even be a path to another universe. This idea has floated around since 1935, when Einstein teamed up with Nathan Rosen to theorize the existence of bridges that connect two different points in space-time. The theory gained some fresh ground in 1980, when physicist Kip Thorne raised a discussion about whether objects could physically travel through these gateways. The problem is that we can't get up close to see for ourselves. We can't even take photographs of anything that takes place inside a black hole. If light cannot escape its immense gravity, then nothing can be snapped by a camera. As it stands, theory suggests that anything which goes beyond the event horizon is simply added to the black hole, and, what's more, because time distorts close to this boundary, this will appear to take place incredibly slowly, so answers won't be quickly forthcoming. Before we can even begin to untangle some of these mysteries, we must first better understand our own universe. If our universe is indeed one of many, the seed it forged inside a black hole may have had its Big Bang 13.8 billion years ago. And even though this universe has been expanding ever since, we could still be hidden behind a black hole's event horizon. Until then, we must continue to ask ourselves, are we truly a product of happenstance, or do black holes hold secrets to the very creation of our reality? What do you think? Let us know in the comments below.